So the next part is to talk about prediction. Like we kind of already talked about prediction in the 12.3 with the regression equation, and we talked about residuals. We talked about in the sample that if it's a r is close to positive or -1, then we could predict values within the scope of the model. In 12.4, we said, well, if it's good for this scope of this model, could it be good for the entire population? And so we did hypothesis testing regarding the significance of the correlation coefficient. So now that we have all those things, we can use prediction. So we're going to talk about, there's a couple of types of predictions. There's one that's going to be outside the scope of the model and ones that are inside. And we're going to do an example of why it's probably better to only keep to the scope of the model. So let's just go to the first example, right? It says data are collected on the relationship between the number of hours per week practicing a musical instrument and scores on a math test. So we're looking at a relationship between the number of hours a student practices a musical instrument and the scores on their math test. They found that the best fit line was y hat is equal to 72.5 plus 2.8x. What would you predict the score on a math test would be for a student who practices a musical instrument for 5 hours a week? So now we didn't see the sample, but I can certainly use my common knowledge and know, well, 7 days a week, that means 5 hours a week is about 30 minutes to 45 minutes a day, which seems reasonable for practicing an instrument, right? So I would say that x is equal to 5, and I would say this is within the scope of our model. And so what you do is you just take y hat and plug in 5 for x, right? Okay, so when you do that, you could just put it in the calculator and you'll get 86.5. And I'm sure you could do it in the calculator. I just want to get to the result so we can make a conclusion. So, so what does this say, right? So this says now that we would predict or assume a student practicing 5 hours per week will earn an 86.5 on her math test. So that it just means that you can assume, and it's a good prediction as long as it's within the scope of the model, right? So what does this mean? Well, if you predict inside of the observed values, then that's called interpolation. So when you're within the scope of the model, like 5 hours per week, that's going to be within the scope of the model for sure. That's interpolation. But if you wanted to use this to predict outside of the model, like far off, that's called extrapolation. And so let's try an example and see why sometimes going outside the scope of the model may not make sense. So find the predicted score on a math test for a student that practices a musical instrument for 150 hours per week. Is this interpolation or extrapolation? Why, and explain. So the first thing, let's go ahead and just note this. We could see that x equal 150 hours per week is almost like, what is that? Like 10 hours, 20 hours, 7, yeah, like a little over 20 hours per day. There's 24 hours in a day. How would, I don't know, maybe, I don't know. So is this within the scope of the model for a week, spending a little over 20 hours a day practicing an instrument? No, because I would think You would have to sleep a little more than 4 hours, right? Go to the restroom, bathe, right? Hopefully. So this would be automatically an extrapolation. Okay, and then because a student would need to practice about 20 hours a day, which seems unreasonable. Okay, and the second part now, let's just see what it is. So remember, all they're doing is trying to predict math test scores. Like if someone, the more a student practices their instrument per week in hours, can we predict that that math score will go up? Right? Is there a positive associated relationship? So let's see. So the model is 72.5 plus 2.8 times 150. And if you just put that in your calculator, you get 492.5. So if a student practices 150 hours per week on their musical instrument, that implies or predicts that a student would earn a 492.5 score on their math test. Do you think that's reasonable? I don't even think all our tests are 492 points in the class. So that's pretty much the result is outside the scope of the model as well. So you could see that, it's intuitive to be like, well, I just want to use this for anything. Why am I restricted to only here? Well, because it's real life. It's not an algebra class. This is like real life. Like, so is it reasonable to practice 150 hours per week? Probably not. Is it reasonable to practice 5 hours per week? Yeah, that's a little more reasonable, way more reasonable, right? So we have to take in consideration when we do statistics, like these models within the scope of like reality. Okay.